7 notes on properties of rectangles. Your objective, you'll be able to recognize and apply properties of rectangles, determine whether parallelograms are rectangles. So, as you already know from your childhood, you know what a rectangle looks like. You've seen this figure quite often. And you know each rectangle and the corners, each one of these corners is 90 degrees. We make the little box to represent 90 degrees. We also know with rectangles that if you take the diagonal or make a line from one corner to the other corner, the opposite corner in a rectangle, it creates two triangles. This green triangle here and this red triangle. And you know each triangle has a total of 180 degrees. Because that's something we've been saying over and over in geometry. You guys know that fact. There's a sum of the interior angles of a triangle is 180 degrees. So these are some key facts that you could remember here, or you should remember from previous lessons. In addition, actually, here's another fact that would be a good idea for you to remember, is that when you draw that diagonal, we also have parallel lines cut by a transversal with rectangles. Just a reminder, well, with this diagonal, we know that this angle here in blue is equal to this angle here in blue. We also know this angle here is equal to this angle. And that's by definition of alternate interior angles. And vice versa, if we also had a line going this way, this red line, we know that this angle is equal to this angle. And this angle is equal to this angle. Let's do 3 just in case. Alright, so let's do some problems here that you're going to be seeing here on your homework. Quadrilateral ABCD is a rectangle. As you can see, A, B, C, D. Or angle BDA, so BDA, this angle right here, is 14x plus 44. And angle BAD, this angle right here, is 3x plus 15. Now we know from previous lessons that angle B up here is a 90-degree angle because we're told that this quadrilateral is a rectangle. So we know this orange angle plus the red angle plus the purple angle, these three angles added together equal 180 degrees because we see that this is a triangle. So that means 14x plus 44 plus 3x plus 15 plus 90 degrees equals 180. Well, I'm going to subtract 90 degrees from both sides already from our equation. So we know that 14x plus 44 plus 3x plus 15, these two angles added together equal 90 degrees. So let me write that out. So 14x plus 3x gets us 17x. 44 plus 15 gets us 59. And that's equal to 90 degrees. Because we already know 180 minus this 90 degrees gets us 90 degrees. So we just subtract 9 degrees already. Then we got to subtract 59 from both sides of the equation, doing our inverse operations. We're going to get 17x equals 31 We divide by 17 to both sides. And we're going to probably get 2 point something. So when I put it in the calculator, the calculator is always helpful. You get the exact answer. So 31 divided by 17 gets us 1.8. 28352, and it just says round to the nearest whole integer. So with no decimal, so when we do that, 1.8 is rounded to 2. So that's why our answer is going to be C, 2. It's going to be C. Oh. Answer C, 2. All right. Number 2 here of our problems. Shall make it a little smaller. There you go. So this problem here. So it's the same setup here. Quadrilateral ABCD is a rectangle. The lengths CB and AD are diagonals inside the rectangle crossing at point E. Find the value of x to the nearest integer with the given diagonal side lengths. Now, something I didn't get to tell you before, which I'm going to tell you right now. When you make two diagonals in a rectangle where they cross each other, these side lengths wind up turning out to be equal to one another. So AE, the length of AE is equal to the length of DE, or ED. And BE is the same length as CE. So when they give us these lengths here, AE is 7x plus 66 and ED is 14x minus 40. You could see that AE and ED, they're the same length, so all we got to do is set them equal to each other. So it's going to be 14x minus 40 is equal to 7x plus 66. We do our inverse operations. We subtract 7x from both sides. We also add 40 to both sides. So we get 7x equals 106. The 106 divided by 7. We're going to get 15.142. And 15.142 rounded to the nearest whole number is going to be B, 15. And that's how you do that type of problem. Let's look at another one. We have quadrilateral ABCD is a rectangle. If angle CDA is 12x plus 17, so CDA, that's this angle right here. If that angle is 12x plus 17, DAC, so DAC, this angle here, in red, is 2x plus 46. Find the value of x. Well, we know that this is a right triangle by definition of rectangle. And we know that when we connect all these lines, connect all these angles, it makes a triangle. We also know that there's 180 degrees inside of a triangle. So we know this angle plus this angle plus this angle equals 180. 180 minus this 90 gets us 90. So we're just going to add up these two angles inside equal to 90. So 12x plus 2x gets us 14x. Then our 17 plus 46, add those together, we get 63. And that's equal to 90. Subtract 63 from both sides, and you're going to get 27, so 14x equals 27. Divide both sides by 14, you're going to get 1.89-ish, which is rounded to 2. So A equals 2. Let's do another one. Quadrilateral ABCD is a rectangle, the lengths CB and AD are diagonals inside the rectangle crossing at point E. Find the value of x to the nearest integer with the given diagonal side lengths. So our given diagonal side lengths are up here in the upper right hand corner, CE and BE. Well, we know that they're equal to each other because we have two diagonals crossing. That's just by definition of rectangle. Since we know they're equal to each other, we set them equal to each other and do inverse operations. So 12x minus 7x gets us 5x. And then negative 32, we add 32 to both sides, so 57 plus 32 gets us 89. So equals 89. We just did that inverse operation, so we set them equal to each other, did inverse operations to get to here. We then divide by 5 to both sides. 89 divided by 5, but that's around 18. Let's double check. 89 divided by 5. 17.8. So, yep, 18. So we see 18. I think we got 2 or 3 more left. So looking at this one, quadrilateral ABCD is a rectangle. If angle CDA, so CDA, this angle right here, is 7x plus 49, and angle BAD is 15x minus 37. So BAD, that would be this angle right here. Find the value of x. Well, I can see that this is alternate interior angles by definition of that. Alternate interior angles. So let's highlight that so you see a little bit more of what I mean. So the line AB and the line CD got those two parallel lines like we're used to seeing. And if we highlight this diagonal, it looks like the parallel lines cut by the transversal that we were practicing earlier this school year. Where these two angles, better yet, we'll do that better. There we go. That's parallel lines cut by the transversal. So you can see by the green and the red are alternate interior angles. And what do we know about alternate interior angles? Well, that they're equal to each other. So 7x plus 49 is equal to 15x minus 37. We do our inverse operations. We're going to get 8x we got 8x is equal to, well, we add 37 to both sides, we're going to get 86. 86 divided by 8. We're going to get 10.75, which rounds up to 11. So we A. Alright, let's try a word problem and then we'll be all done. So looking at this one, dodgeball. A community rec center has created an outdoor dodgeball playing field. To be sure that it meets the ideal playing field requirements, they measured the sides of the field and its diagonals. If AB, aka the top of the court, is 32 feet, BC, which is the right side of the court, is 98 feet, CD is 39 feet, and AD is 98 feet. Well, let me write that out so you can understand a little bit better. So across here is 32, up and down is 98, CD is 39, and AD up and down is 98. The diagonals are both 59. So if I were to draw that in, so both diagonals are 59. I'll just do one diagonal. Because both diagonals are 59, we're good. This passes the rectangular test here about the diagonals both being 59. So that's good there. However, the top length of our rectangle and the bottom length of a rectangle, they have different lengths. Because they are different, we know that this court is not a rectangular court. It doesn't fit the needs for ideal playing field. Even though our right side and our left side do, our top and bottom don't. All three conditions need to be met in order for it to be a rectangle, meaning the top length and the bottom length have to be the same length. The right side and the left side have to be the same length, and both diagonals have to be the same length in order for this to be a rectangle. So the answer to this one will be no. The outdoor dodgeball playing field does not meet the ideal playing field requirements to make a rectangle. Alright, here's your classwork, your homework. Have yourself a good night. If you have any questions, feel free to email me or come to Extra Help. I'll be happy to help you out. Have a good night.